The T2FD, terminated tilted folded dipole, often just called a terminated folded dipole, is a broadband wire antenna originally developed by the US Navy in 1940s. In amateur radio, it is highly valued for its ability to operate across a massive frequency range, often an entire HF spectrum from 80 meter through 10 meter without requiring an antenna tuner. Physically, the T2FD looks like a standard folded dipole, but with a critical modification. The loop is broken at the center of the top wire and bridged by a non-inductive terminating resistor. The balun. The feed point is at the center of the bottom wire. Because the antenna naturally presents a high impedance, a voltage balun is used to match it to a standard 50 ohm coaxial cable. The resistor. The resistor absorbs RF energy that would otherwise reflect back down the feed line as standing waves. The balun ratio and resistor value must match. A common pairing is a 450 ohm resistor with a 9:1 balun, that is 50 ohms into 9 is equal to 450, or a 600 ohm resistor with a 12:1 balun. The tilt. While it can be mounted horizontally or as an inverted V, it is traditionally installed as a sloper, tilted at 20 to 40 degree angle, which gives it a slightly omnidirectional radiation pattern. The T2FD is the ultimate broadband antenna, but it relies on a specific compromise to achieve its broad bandwidth. It has an extremely flat SWR across multiple HF bands, allows frequency hopping or scanning, but the compromise, lossy transmission. The terminating resistor dissipates up to 30% of your transmit power as pure heat. Receive noise. The closed loop design makes it a very quiet antenna, rejecting atmospheric static and local QRM. Equipment safety. Modern solid state rigs won't fold back power due to high SWR, but it requires high wattage components, that is the resistor. To work efficiently on lower HF frequencies like the 80 meter or 160 meter bands, a T2FD still requires significant real estate. The total end-to-end length of the antenna should be ideally about 1/3 of the wavelength of the lowest planned operating frequency. For 80 MHz, this means the antenna needs to be roughly 90 feet long. When transmitting, especially if pushing output from a 100-watt linear amplifier, component selection becomes critical. The terminating resistor must be strictly non-inductive, carbon composition or thick film, never wire wound, as the coil will act as a choke, and rated to safely dissipate at least 30 to 50 watts of continuous heat to avoid burning out during heavy duty cycle modes like FT8.